Dámy a pánové, já vás vítám opět po přestávce. Náš další příspěvek bude od Nicoly Reina z Intelu, to je naše další partnerská společnost. A Nicola Reina nám poví něco o bezpečnosti, o bezpečnostních prvcích, které používají ty technologie, které naši zákazníci mají instalované v našem server hotelu. Thank you very much, Nicola, for joining us, and I'm handing over to you.
Thank you for the introduction. Hello to everybody. Nice to meet you electronically, virtually. I hope I could be there. I will be talking about the security feature of the current generation of our processors. So third generation Xeon scalable processors. And I will be talking about that by introducing what is the current. Sorry, I don't speak your language. I will try to speak slowly and with simple words in order to have everybody with me. So I will start speaking about what is the current landscape, how Intel sees the security, what's Intel's approach to security, and what is Intel point of view on what matters in security. And I will finally touch on our features in the latest generation of Intel's processor. So before going into what is the current landscape as we see, I think it is important also to highlight Intel approach to security. As you may know, Intel has done a public pledge in 5 years ago on security, on transparency, and on readiness and quickness in responding. And I wanted to set these as, if you want, a preliminary to all the more detailed discussion, because this is a way that informs our way of handling security. So in Intel, we handle security in all things related to the product before its launch, in the development, after its launch, and until it goes dismissed, and at all layer, hardware, software, and so on. For these, I think we have the most unique program in the industry, and we are leading a group of industry and partners in a constant evaluation and fixing of problems, which leads to a periodic update of our products in collaboration with our partners. So I call this reliable security, because as users, you don't want just the security of the products as they go out of the box, but also you want it to be reliable all the time. And that is our pledge. And this can be measured really in terms of results with our annual report. I will send my colleagues here a link where you can see the results. So enough talk, just to say that it's not just a point in time, a product in time, but it's really about an approach. So what is today's landscape is characterized by a growing complexity and the growing precision and the variability also of the challenges that security CSO are facing. So here in this slide, we see just categories, really, not really instances of menace. And this is what the security officer will face every day, a combination of these. These are not even anymore accessible to sophisticated users, as some of those can be leased or rent combined. So this is the scenario that we face today as a security officer. So what are the consequences of these tests? Well, the consequence is that can be both financial, so direct financial impact due to the impact of direct business damage deriving from data unavailability or exfiltration. Then there are even worse consequences from my point of view, longer term, if you want. So brand reputational damage, customers leaving because of troubles. It's not even measurable, but it's even more a challenge, if you want. And then there are, depending on the industry and jurisdiction, could be also fines that will add up on the financial impact. So from this point of view, whatever jurisdiction and laws and regulation, you will see a growing number of measures taken against vulnerabilities, and even not even security vulnerabilities, but really a leak in information. You know that all in all, in every country there is a rising concern about data privacy. So what is Intel's point of view? Our point of view, and it's not really because we are hardware producers, but we really think that hardware is the base of security capabilities. Is foundational, if you want. Again, it's not because we are producing it, but because it's from a conceptual point of view. To do an analogy, this is your home's foundation, and your home's foundation is as secure as your home is as secure as your home foundations are. And so hardware is the foundation of all that runs upon it, and must be hardened to provide a solid base to build secure application. Might sound like a truism, but that is it. And this is not, again, to the fact that security is more of a marathon than a sprint. This is something you build upon. So if you lay your foundation early in a good way, then you will be ready to face also new challenges in the future. So starting from this foundation, where we build on top of them. So we build into our silicon features that enable, together with software, using the new performance the new features to enhance the platform security. For example, in the client space, we enable access to low-level CPU telemetry for predictive ransomware by the client security software. On data center space, we enable through the use of dedicated hardware resiliency in firmware update. So it is security enabled by software on top of hardware. Finally, going back to my first point, recognizing the importance of the foundation, the strategic value of getting hold of control of those, also the antagonists are increasingly targeting the hardware. That's another reason to focus our approach on fortifying the hardware base. And this is just from strictly a security point of view. Now, if we enlarge the view and see what is happening in the world in terms of business, we realize that security is becoming central not only to security for itself, but really to develop the business. The world is becoming more connected, so we are seeing growth in data. And in order to process this data, there are new computing opportunities such as cloud, edge, and analytics that are emerging and are really enabling the business. So it's not really just about security; it's really about digital transformation enabling. This transformation drives complexity as the boundary of the attack surface is more and more blurred. You will not really have one single point of attacks, but the and at the center of all of it is really data and the attention to data. So what we see as emerging trend in order to keep the security in focus is really or trends. So encrypting everything, isolating the workloads, and the data, building a chain of trust starting from hardware to reach a final goal of complying with regulatory. So let's say enough of a high-level landscape, and let's see how we do it with a glimpse on the products of the third generation and how they enable this view. So at the center is always, as we said, the data, protecting the data. And usually we always, we think at the data, we have protected historical data in two situations, at rest and in flights, so in storage and during transmission. There is a third pillar, which is in use, we'll go over. So we have to protect this layer. And we do at the platform level by establishing a trust, resiliency, and visibility, and all of it without compromising the performance. So how do we cope with the first two items? So data at rest and in flight from a product point of view using third gen features. We are enabling cryptography everywhere in rest and in flight by introducing new instructions and new ways of using the instructions in our architecture, in our instruction set. So these new instructions are an ideal continuation of what you may know from the past, from the advanced encryption instructions. It's a continuation of that, and that is again to the theme of security as a marathon. They build on top of that, and they are enabling common usages of encryption in transmission and storage. So it's basically the delivery of this new feature comes through libraries, open source libraries that can be used both directly or by libraries used in other products. There is different levels of usage one can take of that. So you have some libraries that are focused on primitives and that you would use in your own products development if you do so. Or there are other libraries that are libraries ready-made. All of this is open source, available on GitHub, because one part of security is also transparency. I mean, and especially in cryptography, these things must be challenged by the community, and that is what we do by open sourcing them. They are also upstreamed to major distributions, and they have there are bindings to the major languages. So that is how they are delivered and used. The results, if you see there, you can see real results. So by using those libraries, and you can achieve in common scenarios such as public key, asymmetric key, up to 8 times faster public key encryption and decryption. In a symmetric key, up to 4 times faster with vector AES encryption. This is used in transmission, in storage, and also other common operation like computation of SHA is accelerated in some common handle. So from the past, we said we built on the past, on the encryption and instruction already existing. We have gone a step further in the sense that we have gone through analyzing the algorithms and introducing new instruction that can implement parallelism in encryption. So. And those are again some results that are achievable with the new instructions. So public key cryptography with up to 5.6x increase in speed on OpenSSL RSA signed with 2048 key length, and symmetric encryption up to 3.3x times on AES GCM, which is the as you know, the transmission most used protocol in transmission. So this is for data in flight and as data stored. So what about the other the other, oops, it doesn't go forward. Yeah. What about the other usage of data in use? This is kind of the new frontier, if you want, because this is and this is even more actual with current landscape. So how to protect data while it is being used and computed? Our approach in Intel is basically this feature, Intel Software Guard Extension. So software guard extension is an approach to what is called in the industry confidential computing. So there are many approaches to confidential computing. Some are more academic, like homomorphic encryption, differential privacy, multi-party computation. This is in reality the most, and the last one is trusted execution environments. This is an example of a trusted execution environment and is the most mature trusted execution environment that is out there. A trusted execution environment basically is a subset of your hardware where it is that is characterized by high security and where it cannot be and when it's secure from third parties. So the SGX is our approach to trusted execution environment. Also, SGX is also, you might have known it from the past. Again, the theme of the security as a marathon. It was first introduced in the client space, then it had a first iteration in the server space, and now as a card. And then finally, it is now in our CPU as a feature of the CPU, integrated in the CPU. So what makes it different from other offer is that it is very, it has a very small trusted compute base. What is a trusted compute base? Is what is left of the system and that you must trust. Trust compute base for SGX is restricted to the CPU and the enclave. The enclave is that safe space that I was talking before. So it is the place where secure computation and data on protected data is done. So when you use SGX, you do not trust anything else than the CPU and the enclave where data is residing. So in theory, all your system, all your stack could be in the hands of adversary, and you are still safe that data is not accessed. So this is especially important in an environment where you have promiscuity of users of the infrastructure, like yes, a modern data center or in cloud. So this protects you even not only from the other tenants, but even from the management, the manager of the data center itself. So it's the highest level of, if you want, secure of security in terms of border, let's say. And what other characteristic makes it different from the other the competition and from other approaches is also the attestation mechanism. Attestation is basically a way to certify that your enclave is sound and safe to work on. So it is in the setup phase of the SGX. There will be an authority certifying through a root of trust that your enclave is safe to run software on, and you can start. This authority can be both Intel, but it can also be managed by you, and in the future will be also available as a service. So, and the uniqueness of this attestation is not only in the setup phase, but also makes this platform very, very resilient in the sense that it will be, it is also used in recertifying the platform after it has been updated due to, well, fixes in security. Again, the theme of the marathon. I mean, it's not, we are constantly watching all our products and testing them and challenging them internally and externally through searchers and bug bounties. So vulnerabilities are discovered, and difference from other platforms, this SGX can be updated and can be recertified to be safe to run products on. So finally, from a practical standpoint, how do you use it? Well, you have, again, the flexibility to go from the most detailed control to, in exchange for a little widening in the trusted compute base, you have to give up some security. You have also faster methods. And again, so you can basically either refactor your application if you do like so, and if you want to go to granularity and most security, you can refactor it using both open source tools or commercial tools, or you can use a lift and shift approach where modern application stacks like containers can be simply lifted and shifted with a very simple approach and put in a secure enclave at the cost of a small widening of the compute base. Finally, the last feature that I would like to speak really shortly is total memory encryption, which encrypts the full system memory. It's yet another feature. Encrypts the full memory for added protection against physical attacks. So it is basically it acts at the boot time. Think of it as a BitLocker for your memory. It acts at the boot time, simple enabling, no software enablement, and it will encrypt all your host memory in one shot. So it will be simply enablement, and it's mainly against physical attacks if you want, and with a really small performance overhead. This is valid in general for all our solution. Our focus is to provide security without compromising the performance. That is our has always been our focus, and it is still so. So in a nutshell, this is the message I want to transmit to you today, that security is becoming not anymore something specialistic, but it with the open boundaries becoming something essential to business transformation. The most secure approach we see is starting from the foundation. So really making sure that you are building something secure on secure foundation today, and that you can trust now and in the future for future developments. And we think that the third generation of Xeon Scalable is a great step ahead, and we will not stop. We'll continue to implement features also in the fourth gen. So I think I even did it with some minutes of advance. So we have, if you want some questions, you can.
Thank you very much, Nicola. Dámy a pánové, Nikola se ptá, jestli máme nějaké dotazy na něj. Žádný dotaz? Okay, Nicola, I thank you so much for your presentation.
Thank you.
I think it's been very instrumental for us to understand how you implement the security measures on the lowest technical level with the high standards. So thank you so much, and we really appreciate you spend your time with us.
Thank you.
Thank you.
Have a good day.
You too. Thank you. Buongiorno.
Buongiorno.